Hello folks, let's try a little bit of new software here, and we're going to be talking about rates of change and limits. So let's get started. The example I'm going to start off with is, let's say you've got a rock that's been dropped off a sheer cliff. What is the average speed during the first 2 seconds of free fall if the equation for the distance being traveled is strictly in terms of time, and it's d equals 16t squared, where t is time. Again, I hear average speed, I think rate of change, and I think it's going to be a slope problem. So I'm going to say that my average speed will be the distance traveled divided by the length of the interval. I can get my distance traveled by saying, since it's the first 2 seconds, I'm going to start at t equals 0, and I'm going to go to t equals 2. And so I'm going to substitute those values into the equation, and I'm going to end up getting to delta d over delta t, which is going to be 16 times 2 squared minus 16 times 0 all over 2. So I'm looking at 64 over 2, which is 32 feet per second. Not too bad. Let's move on. The next one I need to mess with is instantaneous speed. Now this one is going to be a bit of a mind warp, so hold on tight. Here we go. I don't have a radar gun, and I'm still just looking to use a stopwatch and the equation to figure out how fast it's going at 2 seconds. So what I'm going to do is I'm going to bend the rules for a second. I'm going to say, all right, well, I'm going to try and come up with a slope again, but this slope's going to be a little bit weird because I want to find the time at 2, and I'm going to say I'm creating some artificial time at 2 plus h. Now, when I do that and I substitute these values into that 16t squared again, I'm going to get this expression. I just substituted in 2 plus h here, and this is going to be 16 times 2 squared. I dropped the squaring there. Now I'm just going to need to FOIL this out, which is going to get me to there. And then I distribute, which gets me to here. And then I'm going to factor out an h and an h, and I'm going to cancel that h with this h, which gets me down to 64 plus 16h. But take a look. Remember I said I wanted this to be 2 plus h, where h was really, really small. How small do I want it? I want it to be 0. So what I end up doing in this case is I'm just going to say, since h equals 0, my final speed is going to be 64 feet per second. Okay, not so bad. Now, let's get to the meat of what we're talking about today, which is limits. And as we're going through this, you may want to replay this and pull it back, but we'll get to someplace good here. All right, so let's get started. You can look up a definition for limits, but what we're really looking at and what it boils down to is going to be this. When I'm given something and they're asking me what this means, that expression is kind of a numerical representation to say that the value of, I want you to find me the value of f of x when the x coordinate is infinitely close to 2. I'm not looking for when it's 2, I want it to be infinitely close to 2. And here's the big point here. When you're asked to find a limit, your answer will always be a y coordinate. It will always be a y coordinate. Now just keep that in mind for all of these graphs. I'm looking for the y coordinate. Even though I'm using the x coordinate, I'm trying to find what the y coordinate is. So let's see what we can do on this. Next up, to try and find the value of this function, the limit as x approaches 2, I'm going to need to come at it a little bit differently. First thing I'm going to do is I'm going to look at the limit as x is approaching 2 from the left. Now, this negative sign after it means from the left. And, well, let's see. As I'm approaching 2 from the left-hand side, I'm going to track on the graph and see what y value I'm getting really, really close to. Well, it sure looks like I'm approaching 3 there. Okay, not too bad. Next, change gears and let's see if we can find something else. How about I try and find the limit as x approaches 2 from the right. So let's see, I probably should have the f of x function written in there. I didn't, but well. So I'm going to say as I'm approaching 2 from the right, I'm going to track in on this and say, well, what y value am I approaching? It looks like I'm approaching 3 again. Now, when your limit from your left matches your limit from the right, that's good news, because what that means is I actually have a limit. In order for there to be a limit, the limit from the left has to match the limit from the right. And in this case, we're going to say because it does, my limit is 3. Now, I'm going to have 1 or 2 observant people comment that, wait a second, what about this here? That's the value of the function. The value of the function is irrelevant when it comes to the limit. It many times will be the same as the limit, but it absolutely positively does not have to be, and you're not trapped by that. That's why I'm saying it's infinitely close to 2. It's not at 2, it's infinitely close to 2. So hopefully that makes sense, and we're going to take a look at another one of these visual examples. So here we go. Let me clear this stuff out. Here I've got a nice little graph, and I'm going to say, all right, well, let's see where we can get to on this. Get this out of the way, and we're going to say, all right, what is the limit as n is approaching 0? All right, well, let's kind of track in on this one, and well, let's take pink. As I approach an x-coordinate of 0, I'm looking at the same value from both the left and the right. It's a value of 2. Okay. Next up, let's see what else we've got here. What is the limit as n is approaching infinity? Okay, infinity. Well, let's see what happens. As I'm going to infinity, that means I'm going in this direction, but I need to be on the graph. So what's happening to the graph? It looks like it's completely flattened out here, so I'm going to say that this one's also going to be 2. Cool on that? Excellent. Moving on. Next, I'm going to look for what is the limit as n is approaching -5 from the left. Let's see here, -5 from the left. Well, -5 is here. So as I'm approaching from that, oh wait, I'm on the graph. What's happening to my y-coordinate? It's going up. And how much is it going up? It's going up without bound, so we say that it's going to be approaching infinity. Okay, not too bad again. Let's see where else we can go. Next up, let's see here. How about I'm approaching -5 from the right? Once again, coming in this direction, but I need to stay on the graph. What's happening? Once again, it's coming in without bound, and it's going to negative infinity this time. All right, well, let's see if we got another one here. I'm approaching, you know what, my guess is that's a typo. That should probably say, instead of that, it should probably say n is approaching -5. Okay, so if I'm approaching -5 there, I'm going to also come back and comment, wait a second, these don't match up. When that's the case, the limit just plain does not exist, and you can write DNE, and no teacher is going to ever argue with you on that. Okay, as long as you say because the limit from the left doesn't match the limit from the right, you've proven that there is no limit for that value. Okay, let's move on again. Please take a look at this graph. And in this case, what I'm going to ask you to do is, once again, see what you can do about adjusting it and see what you can come up with on this one. Go ahead and pause, see if you can fill it in. What are your values? What do you see? I'll pause mine and fill in some values, and we'll compare. Okay, hoping you guys did well. Hopefully it's fairly straightforward on this. Once again, noticing the limit from the left does not match the limit from the right, so the overall limit does not exist at 2 because they don't match up. And all right, let's see what we can do about coming up with another example here. Ooh, these look pretty. Got 3 different graphs. Once again, let's pause these, and I'll kind of walk you through answers, see if you can come up with stuff. Okay. Rather than writing all of it out, what I'm going to do is just tell you visually what it says. It says I'm approaching 2 from the left. So as I'm approaching 2 from the left, I'm coming in up here. I'm going to be saying that this value is going to be 2. Over here, I'm approaching 2 from the right. So what happens is I go from the right, I'm approaching 0. So here it's 2, here it's 0, so therefore the limit there does not exist. However, I do have a closed dot here, which means that, yes, f of 2 does exist, and it's equal to 2. I'm going to look here, and I'm going to say that the limit is f of x as x approaches negative infinity. What's happening? It looks like it's flattening out to a y-coordinate of 0. And here, as I'm going to positive infinity, it looks like I'm going to approach 2. Once again, over here, again, if you want to pause and work on another one, okay, feel free. But I'm going to keep rolling. I'm going to say the limit as x approaches negative 2 from the left. Well, I'm approaching a y-coordinate here of 0. From the right, I am approaching a y-coordinate of 0. So therefore, since the limit from the left matches the limit from the right, we're going to say that the limit as x approaches negative 2 is going to be 0. Cool there. But the value of the function is going to be 3. Once again, they don't match. What happens as I'm going to negative infinity? What's happening to my y-coordinate? My y-coordinate continues to go up and up and up, so I'm saying it's infinity. And as I go to positive infinity, my graph continues to go up, so my y-coordinate would be infinity there. Okay, this last little graph I want to take a couple quick seconds with, and I do want to emphasize on this one, be careful. So my limit from the left as I approach 0 is going to be 3. From the right, it's going to be 3. So the limit is 3. And here, g of 0 is 3. All of them are 3. Yay! Nothing interesting. But take a look at this one. What's happening as I go to negative infinity? It's acting like a sine wave. That's a problem because it's oscillating. It's not closing in on a value. As a matter of fact, it keeps bouncing back and forth. When you're looking for a limit, you want it to close in on a value. It's not. It keeps going up and down in between what looks like 2 and negative 2. So we would say because it keeps bouncing up and down, that the limit does not exist. Okay. On the other hand, when we look at the limit as x approaches positive infinity, even though it's kind of oscillating, it's getting closer and closer to a value of 0. So in this case, I'm going to say it's going to be 0. Okay, so next up, let's see what we can do for the next one. Okay, on this one, what I would like you to do is please pull out your graphing calculator. Or I suppose if you desperately needed to, you can pop this into Desmos. I'm going to pull out my graphing calculator, which I happen to have handy here. And I'm going to say, all right, I want to enter this into y equals. I'm going to hit alpha, y equals to pull up the fraction bar. Hit enter. And I'm going to go sine of x, close my parenthesis, over x. Okay, so far so good. Next thing I need to do is I need to go zoom, and one of the nice features here is something called zoom trig, which is 7. I'm going to pop that in place, and I'm looking at this and I'm going to say, cool. And I'm going to ask you to find the limit as x approaches 0. You're going to say, that's easy, Mr. Johnson. All I have to do is hit the trace button. And I can take a look, and I can say from the right, as I get closer and closer, it appears that I'm closing in on a value of like 1. And as I close in from the left, once again, I'm closing in on a value of 1. But what do you notice? At 0, there's an open dot there. The value is not defined at x equals 0. So therefore, the limit would be 1, but doesn't mean that I have a value. I also want to show you something else on your calculator. Please do me a favor and follow carefully. We're going to hit second, window, which pulls up the table set. And what we're going to do is we're going to start at, say, 0, and let's go up by, I don't know, let's say 0.05. And now I hit table. I'm going to go second, graph, which pulls up the table. And you can now look at these various things, and you can see that as I'm getting closer and closer from the right and closer from the left, I'm still getting values that are very, very close to 0, or not 0, 1. So we can use graphing calculators to help us to try and see things a little bit differently. We're not going to be doing a ton of that, but I want you guys to look at that today. Okay, so I'm done for today. I'm now going to say you might want to grab the first day's worth of kind of practice problems, give it a shot, and or if you want to keep going, I'll have the next one loaded up as quickly as possible.